Here's another video on determining whether or not an equation is linear or not. So first of all, recognizing the three most popular forms of linear equations is kind of essential. So if you see an equation in this form, what you would see in a specific case would be something like this. All right, so you see a y value, you see an x value here, or a variable for y and x. You see a number in place of the m and a number in place of the b. This is called slope-intercept form. This next form is called standard form, and again, we're going to keep the x and the y in most cases, but we're going to have a value in for a. Most would say that that value for a has to be positive, so I'm going to say like 3x, and we'll go with minus 5y equals 10. So you can see that I've replaced the a with a 3, the b became a negative 5, and the c became positive 10. It matches up almost perfectly, actually it matches up perfectly with this general version of the standard form. The third popular form, albeit the least popular of the three, is called point slope form. Again, I'm going to keep the y value. I'm going to plug a number in, excuse me, for y1, something like that. I'm going to plug in a -1 for m, so it's just going to show up as a minus in front of that parenthesis, and I have something like that. This is in point slope form. And again, I'm not asking that at this point that you understand what any of these things mean. It's just say, oh, I can see this and this are pretty much the same thing, okay? Now, there are some cases when you'll see an equation and you'll be like, it doesn't really look like those. And there are some red flags that will trigger you saying that this is not a linear equation. First of all, any kind of exponent in the x or the y will automatically disqualify it from being linear. Okay, so if this was x squared, x to the third, or y squared, any exponent at all, okay, and that includes negative exponents, which would end up putting the x in the denominator, or if you see the x in the denominator, that's bad news, that is nonlinear. If you see any strange symbols like this absolute value or a square root, or if you see any, like if you look at your calculator, you can see sine, cosine, or tangent. If you see something like that in there, it's nonlinear, okay? And then here's just another one. We have the x right here. We have a number in front of the x. We have a minus thing. So this one almost looks a little bit like this mx plus b, but the x is not beside it, multiplying it, it is in the exponent. So that's definitely a no-go. So these are all nonlinear. Then we get to this one down here, which is a linear equation in disguise. Notice that there's no funky symbols. There's no strange exponents. It's a number in front of the y, it's a number in front of the x, and it's just a plain old constant over here. If I did some manipulation, we would find, let me just add 10 to both sides, which I'm allowed to do, obviously. And I get 5y plus 10 over here. And if I subtract 5y from both sides, I get 10 equals 3x minus 5y, which then, of course, I can flip around to be this equation. Now, if I zoom out, we're going to see that same equation right here. So this equation that I started with ended up looking like this equation. So occasionally you're going to see linear equations that we can manipulate and put into one of the three forms. So I would definitely call this linear. And in fact, I would classify it as the standard form of linear equations.